Hello everyone, this is Teacher Ang. Today we are looking at NMOS 2024. So NMOS recently ended and this question is from round 1, question 24. So let us generate a sequence of numbers by multiplying 2 to the preceding term to get the next term with 2 as its first term as follows. So you can see the number sequence. It starts off 2, multiplied by 2, 4, then 8, 16, 32, 64, 128, so on and so forth. What is the remainder when the sum of the 40th term and the 67th term of this sequence is divided by 5? Can you see what the most straightforward way to solve this question would be? Yes, it will be to just count all the way until we reach the 40th and 67th term, right? It will be 256, 512, 1024, all the way until we get the 40th term and the 67th term. And what do we do next? Yes, we find their remainders. The remainder of the 40th term and the 67th term, and we add them up together. But this 40th and 67th term, they will be so large, right? And if you count, you just keep counting and counting and counting, and gonna grow old. Right, so there has to be a faster way to do this. So this question is asking for the sum of the remainders when it's divided by 5. So let's see what happens if we divide the simpler numbers by 5. When we divide 2 by 5 to get a remainder, there is a remainder of 2. Next, 4. Next, 3. Next, 1. Followed by, 2, 4, 3, 1, 2, and 4. Do you notice something here? It seems like the numbers, yes, they are repeating, right? And how many numbers before it repeats again? Every 4 numbers, it repeats 2, 4, 3, 1, then 2, 4, 3, 1, and then it will keep going on 2, 4, 3, 1 all the way. So with this, we can actually find the remainder of the 40th term and 67th term, right? But are we sure? Let's see. Let me give you an example. Now, we have teacher Ang. I suddenly became an old Japanese teacher, and 3 students. Okay, I have 4 apples that I want to give to these 3 students. So, I give them up. There they go. And how many apples do I have left? I have 1 left. Right? And the calculation to find this is 4 divided by 3. We get 1, remainder 1. Okay, now I have double the apples times 2. Right? Originally I have 4, now I have 8. If I give them away, what happens? Let's see. When I give them away, the number of apples that the children receive is double, right? Originally they have 1, now they have 2. And what happens to my remainder? The remainder also doubles. Let's see, does it always keep doubling? Now, we find that the equation is 8 divided by 3 equals to 2, remainder 2. So we have 2 apples left. Now we double again. So previously I had 8, now I have 16 apples. And now 16 apples, if I give them 3 each, it definitely must mean that they have double the apples and I'm left with double, right? Can you spot the mistake here? We are giving 1 apple to 3 children. And here we have 4. So doesn't that mean we have to give them out 1 more time? We give them out 1 more time and we are left with 1. So, yes, the remainder does double, but if the remainder goes above 3, then you will have to give them away and the remainder changes, right? So we have 4 left and then we gave 3 away, so we are left with 1. So let's come back to this question. We see the original remainder when we divide by 5 is 2. And then next is actually multiplied by 2, right? 4. and 4 multiplied by 2, we get 8. But we have 8, we can divide by 5 again. We can give out another 5 and we are left with 3. And 3 times 2, we get 6. 6, you can remove another 5 to get 1. And then it goes 2 and 4 and so on and so forth. So indeed, this is a fixed pattern, right? It goes 2, 4, 3, 1 all the way. It will multiply by 2, but if it gets bigger than 5, 5 will be subtracted. Right? Okay, so we know that it does go in this pattern all the way. How do we find what is the remainder in the 40th term? First we can find and remove all the groups in a pattern. Right? The number in a group is 4. There's 4 numbers, so we can divide 40 by 4. And then we get 10. This 10, how can you use it to find the remainder? Is it useful? Not really, right? All this tells us is there are 10 groups of this pattern. But are there any leftovers? No, right? There are 10 full groups, which means that 40 divided by 4, we get 10 and it's a remainder of 0. This remainder 0 tells us that there are full groups of 4, which means that the 40th term will be in the last digit of one of the group, right? And the last remainder will be 1. Okay, now how can I find the remainder of the 67th term? I can also similarly divide by 4 and I get 16. Oh, this time we know there's a remainder 3. And what does remainder 3 tell us? It tells us it is the third number in this pattern. And the third number is the number 3. So now we have the remainder of the 40th term and the 67th term. What is their sum? Yes, it is simply 4. And there we have found the answer. So let's summarize what we learned today. First, if we have a very big problem, right? There's a long sequence with big numbers and we want to find for a very big number. First, we can try to solve from the simpler ones first. Right? We start from the beginning and solve the simpler one first and we can find a pattern. Once we find a pattern, we are able to solve and work out for the answer. What else have we learned? In these questions, when they are multiplied by 2 and 2 and 2 all the way, what happens to the remainder? The remainder also is multiplied by 2. However, if it goes beyond any number that we are dividing by, the divisor, then we have to subtract the divisor. If not, we have an extra question. Let's test if you remember what we've learned. So you can have a look at this question. Let us generate a sequence of numbers multiplying by 3 to the preceding term to get the next term, with 3 as the first term, as follows: 3, 9, 27, 81, 243, so on and so forth. What is the remainder when the sum of the 53rd term and the 88th term of this sequence is divided by 5? So this question is quite similar to the previous one, right? Just that we are changing some of the numbers. So let's see if you can solve it. You can leave your answers in the YouTube comment section below. If you need any help, you can contact me via my personal WhatsApp, and feel free to join our study groups if you haven't joined yet. See you next time. Bye-bye.